Welcome everyone. Welcome to the 5th of our stream compensatory mitigation webinars. We're happy that you all could join us today. I see that people are still logging on, so thanks for joining us. We really appreciate you participating in this webinar series. My name is Rebecca Kisslinger. I'm a science and policy analyst at the Environmental Law Institute, and I direct our wetlands program. This webinar series is hosted by ELI, and it was developed in coordination with an advisory committee of stream mitigation experts. And it's funded by an EPA Wetland Program Development Grant, and we thank you all for your support of this series. So for those of you new to this series or to ELI, we're a nonprofit law and policy research organization. We're based in Washington, D.C. Our wetlands program provides timely, balanced information on wetlands, law, policy, science, and management through research, education, and convenings like this webinar series. We have a lot of information on our website and resources there as well, and you can also join our mailing list from the website, so please log on, check it out if you haven't already, and join our mailing list. So we have a really great lineup of webinars for this series. We kicked off the series in July with a discussion of the status of stream compensatory mitigation. We've had webinars on assessing stream functions and conditions, on barrier removal and the watershed approach. And we have a really busy spring coming up with this series. We'll have webinars on defining and using reference, credit debit determination, stream restoration for multiple purposes, as well as a webinar on long-term performance of stream compensation sites and restoration sites. And then we'll finish up in June with a concluding webinar. So I hope you can join us for those. You can find all of the presentations and the recordings of the past webinars on our webpage. And there are also other resources there. The URL is the top one on this screen. I also have the URL for this webinar here. If you'd like any more information or you have any ideas for future webinars, feel free to always, anytime, email me at the address on the screen. So great. We're really very excited for today's webinar, and we have an excellent panel lined up. So today we're talking about monitoring and performance standards. Monitoring the performance, as you all know, of compensation projects is really essential to ensuring that the planned improvements of a mitigation project are actually observed in practice. So for this webinar, we're discussing monitoring performance standards. We're going to talk about requirements and practice. We're going to talk about the development of biological performance standards. And then we're going to finish up with a presentation on monitoring fish response, which should be really exciting, and monitoring that response at multiple scales. So looking forward to that, and we have just a really excellent panel lined up for today. First, we have Michelle Matson. She's a restoration ecologist and mitigation specialist at the U.S. Army Corps of Engineers Institute for Water Resources. Michelle is a stream and wetland ecologist with over 20 years of professional experience as a consultant and as a regulator. She's a compensatory mitigation subject matter expert and the IWR regulatory team budget manager. She supports national and regional training courses in compensatory mitigation and has spent her career in the field working with restoration teams to design, install, and monitor restoration projects and programs. Michelle is a supporter of using functional and conditional assessments in regulatory and restoration practices, including in informing the location and design of sites and short and long-term monitoring performance and condition of sites. Then we'll be hearing from Eric Somerville. He's from the US EPA Region 4. Eric has split his 20-year career equally between the public and private sectors, and he's presently an environmental scientist at EPA Region 4 in the Water Protection Division in Athens, Georgia. In recent years, Eric's work has increasingly been focused on wetland and stream mitigation policy and the development of technical tools and methods to enhance implementation and evaluation of mitigation projects. Eric has served on interagency mitigation review teams in 3 states, and he's presently serving on the Georgia Interagency Review Team, which is chaired by the Corps Savannah District. And finally, we have Phil Roney. He's a Vice President and Principal Scientist at Kramer Fish Sciences in the Watershed Sciences Lab. And he's also an affiliate professor at the University of Washington School of Aquatic and Fisheries Sciences. Phil has 29 years of experience as a fisheries and restoration scientist. His research has concentrated on assessing, planning, prioritizing, and evaluating numerous various watershed restoration techniques. Phil regularly teaches courses and has published numerous papers on restoration science, including the comprehensive books Stream and Watershed Restoration, A Guide to Restoring Riverine Processes and Habitat, and Monitoring Stream and Watershed Restoration. Phil received a Presidential Early Career Award from the U.S. President and a Certificate of Achievement from AFS for contributions to restoration science. So as you can see, we have a really, truly stellar panel, and I'm excited to turn it over to them. But before we do that, I just wanted to go through a few logistics. All the participants are on mute right now, but we really, as always, encourage your participation in this webinar, and we encourage you to ask as many questions as you have. Most often people do that by typing in a question in the question box. And I usually in the webinars try to get people to get warmed up on that question box by typing in right now. Let us know where you are, how many people are listening from your office. It gives you a chance to get warmed up as well as to let us know who's out there, make sure you can hear me, and how many people are there. So great, those are coming in. I really appreciate you doing that. Again, if you have any technical questions, please email me and I'll do my very best to try to fix those while we're up live. The URL again is here for this webinar. The presentations are all there now, so you can find those there, and we will post the recording of this webinar when we have that available. So with that brief introduction, I'm going to turn it over to Michelle to kick us off. Okay.
Okay. And can you tell me which screen is being?
Yeah, right now you're on your presentation mode.
Okay. Oh, I'm sorry.
Oh, cute.
There's my little one. So sorry.
No worries.
Okay, so I'm not sure how to switch screens. Hold on a second. I'm very sorry. I should have known how to do this.
I think maybe if you just go to the regular slideshow instead of presenter mode.
It's just not letting me. I'm very sorry.
Try that. There we go.
Is that what you got? Okay.
We're great.
Yay!
Thank you.
Sorry. Hopefully that does not set the stage for the rest of the presentation. I do also think, and I'm not able to move it. Hold on. There we go. It's caught up to me. Okay. Woo! There we go. Okay, thank you very much for having me. Hopefully the rest will go a little more smoothly. I'm just really going to set the stage at kind of a high landscape level for the other speakers and talk about developing performance standards and a monitoring program for sustainability. So I will quickly lay out the regulatory setting because regulations aren't all that exciting, so I won't spend too much time on that. Talk about performance standards, and then monitoring programs, and a tiny bit on management, including the interim, so that short-term period monitoring and management period, and then long-term management and adaptive management. I'm not going to go into much detail on those at all because, as Rebecca had mentioned, there are several other webinars that are going to be provided later this year that go into more depth on those topics. Okay, so regulatory setting. Per the mitigation rule, the 2008 mitigation rule, compensatory mitigation involves the actions taken to offset unavoidable adverse impacts to wetlands, streams, which was pretty much the first time that was included in codified in regulations and other aquatic resources. So I just wanted to lay out that we're talking about compensatory mitigation, not restoration for the purposes, through grant funding or for the purposes of just wonderful restoration. This is, we're really focusing on compensatory mitigation, meaning that it's required by the regulations. And so the standards and reporting requirements are often very different. Okay, so within the mitigation rule, there is an outline for mitigation plans. Every type of compensatory mitigation site, including permitted responsible mitigation, mitigation banks, and in lieu fee project sites, all have to have mitigation plans. Within those plans, 12 components are required to be a complete plan. And so today, I'm going to focus on, performance standards and monitoring requirements, but really all of these things are, not all, but most of these things are interconnected, right? And so it's hard to look at one thing in a vacuum. And so as the ecologist in me has a hard time just talking about performance standards. So I will go off into a couple different directions and then hopefully bring it back so that all of you guys can understand what I'm trying to say. And so, here's really it, right? There's one component are the project goals and objectives in a mitigation plan, but those lead to performance measures and ecological performance standards, which is what we're going to focus on later. Those performance standards give rise to suitable metrics and protocols, so methods and tools, functional and conditional assessments, and all of that approaches, and as well as the monitoring program, how often you monitor, what level of detail of the data you need to collect, all comes, it's sort of this chain reaction. And then management, of course, follows that, that same trajectory. Okay, so measuring mitigation performance is outlined in the mitigation rule. In several different categories. There are administrative measures, then there are ecological performance standards, which I think most of us are more familiar with. It is required that these performance standards, because it's a regulatory setting, that they need to be enforceable, and therefore they must be observable, measurable, and achievable, right, in order to be enforceable. And then there's adaptive management. Oh, I didn't realize that I had graphics, like fancy graphics. Okay, so what are administrative measures? These include things like site protection, financial assurances, and long-term management. And financial assurance, site protection, all of these things are very important to protect a site, particularly a compensatory mitigation site, over the long term, so that they are sustainable into the future. And it makes sense from a regulatory standpoint because impacts are typically permanent, right? And so our compensatory mitigation sites should also be permanent to the extent that is practicable. And this is an area where I think a lot of compensatory mitigation practitioners, both consultants and applicants, have a hard time accepting this complexity, right? Site protection instruments are difficult and can be expensive because lawyers need to help develop them. Financial assurances protect us, particularly the environmental community and the regulatory community, to ensure that the construction of our mitigation sites actually happens and that the monitoring of the sites occurs, and that if it's not successful, we can do maintenance or replace it. And then, of course, long-term management, right? We try to design sites to be sustainable, but most need some level of management into the future to ensure that they continue to provide functions and services. Okay, so ecological performance standards need to be based on attributes that are objective and verifiable. I've already said that, based on the best available science assessed in a practical manner, and these are listed in the rule. These are the parameters that are laid out on how we as regulators review proposed performance standards. But this is what we're expecting from our applicants and consultants. And they need to be based on variables or measures of functional capacity when available. What am I doing here? Okay, so restoration of natural processes are difficult, right? And so monitoring those processes are also very difficult. So I try to advise people to develop their performance standards and their monitoring tools to be to cover the spectrum of complexity, so that we can better manage the site into the future, right? And so that we can get a better understanding of how that site is functioning and providing services. And so I like to recommend providing a suite of monitoring tools based on the EPA's level 3 approach to monitoring. So this is level 1 is this, resource inventories or remote sensing, right? And this could be things, and I'll provide examples in a bit, like wetland location, size, classification, and performance standards can be written to use this level of monitoring tool. Level 2 assessment tools are rapid field-based assessments such as HGM or the California Rapid Assessment Method, or other assessment tools. I think one of the previous seminars or webinars was on stream functions and conditions. So you've probably heard a bit about this. And then level 3 assessment tools, I think, are more what we usually think of as monitoring performance standards. And these are these intensive assessment of specific functionality or indicators of functionality. And so this is, evaluating hydrology, soils, vegetation, water quality, and the next speakers are going to talk more about monitoring at this level. Okay, so developing ecological performance standards. As I said, these are all tied together, right? So you have your goals, which is the statement of the intended outcome. What will that mitigation project accomplish? What type of wetland habitat? How large? What species is it going to support, etc. Objectives are these features critical to that desired outcome, right? So what functions and values will get us to achieve those goals? And then the performance standards demonstrate how each of these objectives will be achieved. And we define those performance standards by including an attribute, the level that's necessary to achieve the performance standard, and then the time period in which the performance standard must be achieved. The monitoring program to evaluate performance and the adaptive management program that allows for flexibility feed into these performance standards, right? And vice versa. I should probably have those arrows going both directions. Okay, so ecological performance standards can be grouped into buckets to, just to be easy. So measuring physical, biological, and chemical aspects of compensatory mitigation. These can be measured independently, or they can be measured collectively. And so this is where it gets to those different scales, right? Some of these can be measured utilizing that level 1 assessment tool, like mapping the size of your restored wetland area, versus, benthic macroinvertebrates, which is certainly a level 3 assessment tool. But your performance standards, your ecological performance standards, should include a few performance standards that fall into each of these buckets. We in the regulatory community do not expect you to have, a super exhaustive list of performance standards, but you should be looking at each of the category of functions of your wetland or stream site in order to get at that, is it achieving the overall goal of the project? So, I always tell people, 2 or 3 performance standards based on the physical attributes of the site, biological attributes of the site, and the chemical attributes, and they need to be things that matter, right? Not just the ones that are easy to monitor, and obviously not ones that are just really too difficult to get at. Okay, so here's just an example of level 1 monitoring, remote sensing and mapping. You can map the boundary of the site. We all do this, right? But we don't think of it as performance standards potentially. And so this tool is very easy over, if you have a site that you can't access on a regular basis, or you're looking at invasive species presence, and you have a performance standard that requires you to treat invasive species. In fact, that's my next example, I believe. So here, an example maybe of a performance standard that falls in that level 1 monitoring category could be 32 acres of jurisdictional waters of the United States and adjacent riparian habitat will be established by year 5. So remember I said that each of the performance standards should have an attribute. In this case, it's jurisdictional waters. The level of achievement is 32 acres, and the time period in which that must be achieved is year 5. Okay, so here's another example of level 1 monitoring, again, remote sensing and mapping. This is an example of mapping invasive species. This is on the Otay River in South San Diego County. And the performance standards is the 5-mile continuous stream site, including the riparian zone and buffer, will be treated to eradicate arundo and tamarisk by year 10. So the attribute is arundo and tamarisk, which are easy to see and identify using aerial photography. In fact, sometimes you can find clumps on the aerial photography that you're not getting when you're traversing the site because it can be just difficult to get to. The level is 5 years, and the time period or 5 miles, I'm sorry, and the time period is, by year 10. Okay, so level 2 of monitoring tools, again, are these rapid assessments of function or condition, and some of those examples are HGM, CRAM, the California Rapid Assessment Method, Texas Rapid Assessment Method, Ohio. There are many rapid assessment tools that are being developed, and as Rebecca mentioned, I am a huge advocate of functional and conditional assessment tools, and that's because even though they're level 2 and they don't assess function directly, there's always pros and cons to every tool, right? They're supposed to be part of this toolbox, right? We can't just rely on one tool. But the great thing about these tools is it gives us this overall picture of the site. We can compare it to conditions from other sites within the watershed or subbasin or region, and they are rapid and therefore much more affordable typically to implement than that level 3 assessment data that needs to be collected during that short period of time. So these level 2 monitoring tools can go into the long-term management and help advise the manager on when, if the score starts to drop, when they need to go back out and start assessing in more detail to find out if there's a problem at the site. So I'll get back on track here. The performance standard example here would be, this 5-mile stream restoration site must meet or exceed the CRAM target scores for individual metrics by year 3 and year 5 as provided in table 3. Okay, so you see here these are CRAM attributes on the left-hand column here: buffer, landscape context, hydrology, and then structure, which includes both physical and biological structure. There's a pre-restoration site scores. Those are actual scores that are collected. The post-restoration baseline score in this example is not done yet, right? Because this was something that I had put in a mitigation plan forever ago at the beginning of use of CRAM. And so, but after construction, a new baseline needs to be established there. And then these the reference site scores. You know, it's wonderful if we can use reference sites whenever possible. And I think there's a webinar in the future of using reference sites. And then the year 3 and year 5 scores here are the ones that we projected, looking into the future of what can we obtain at this site in light of existing constraints at the site, right? You're not just going to put out that, oh yeah, I'm going to get, you know, the highest score possible at this site. That's not realistic. Nowadays, you know, we have so many impacted watersheds, alterations to hydrology, alterations to soil, habitat, etc. So in using these tools, we need to be very realistic about how we project our scores and sort of promise, if you will, to the regulatory agencies what we can attain. Okay, so those are the projections, and those are the performance standards here, right? These metric scores, not the overall score at the bottom, but the metric, the individual metric scores, because the overall score, you can get there in many different ways. It doesn't tell you a whole lot about it. It's those individual metric scores that will tell you that, hey, I'm not doing well on biotic structure, or I'm not doing well, like my hydrology is way off, what's going on, what did I do wrong? How do I adapt my restoration site? Okay, so level 3 monitoring, this is just a quick example. I know that most people on the phone are more familiar with level 3 monitoring, you know, going out and assessing benthic macroinvertebrates, doing plant transects, quadrats, mapping and removing invasive species, all of those things that we do as biologists or ecologists or hydrologists, whatever it is. You know, you're taking water samples, all that stuff is level 3 monitoring. So here's an example of hydrology monitoring at a mitigation bank in northern San Diego County. And this included their monitoring for a few years before the bank was approved. They have groundwater monitoring wells across the farm. Here you see in the diagram on the left-hand side, I think there were 9 or 10 monitoring wells that helped us understand, you know, what elevation are we going to grade to, not just utilizing the reference site up above, but really trying to understand the soils and the variation in groundwater over the year and in drought periods, because California, as y'all know, does not get a whole lot of rain. In San Diego, it's like 10 to 12 inches on average. So you really, designing a floodplain restoration site, need to understand what that variation is over time. So I don't think this is one of their real performance standards, but this is what I've got here. Shallow groundwater across the floodplain wetland shall be within 18 inches of ground surface during the wet season, which in this region is October to February, and then 36 inches of ground surface during the dry season based on well data, or, and this is important, or as observed in the approved reference site by year 5. And so by year 5 is because this site had, 10 feet of fill on it for a long time, plus construction. It very well could be, heavily compacted, and we need time for those plants to get their roots in there, break up the soil, and let the groundwater sort of do its thing with aerating the soil and whatnot. So that was that's sort of my little theoretical performance standard there. Okay, so this looks like, I am not a sci-fi guru, but when I started trying to put, nor am I an artist, obviously. So when I started to try to put together a diagram that sort of, explained what I visualized in my crazy brain, it came out looking like the zombie, which sort of made sense because it's the monitoring program that never dies. And really, monitoring does continue. I shouldn't say forever, and I shouldn't say in perpetuity as a regulator, but really it goes on and on because, things happen. People trespass and so on. So anyway, let me get focused here again. So the basic needs are, or the basis of your site is understanding first the watershed needs, and a previous seminar talked about the watershed approach. The mitigation rule requires that we identify sites based on the watershed approach. that baseline data that you're able to collect so that to understand both the subbasin, the watershed, and the site and how you might design that, and establishing your objectives for the site. And then on the outside of this alien face here is the design of the site, development of the ecological performance standards, construction, installation, and monitoring, which is usually about 120 days at that sort of beginning phase so that you can see, are your plants in the right location, are they surviving, etc. And then you go into this interim monitoring period of 5 years minimum. So the mitigation rule says 5 years minimum. Most large sites, and it does say, I don't know the exact words, but it's, for difficult to replace resources, the monitoring period should be or must be extended. And many mitigation banks in particular now, because those are larger sites, or sensitive resources like vernal pools on the West Coast or maybe prairie potholes out here, those take a much longer period of time to establish whether or not they're on the right trajectory to mature. So that's a 5-year minimum interim monitoring period, and then ecological performance success and sign off. Those are these, interim performance standards. And in there's this adaptive management, right? There's always adaptive management, no matter what site. I've never had a site, nor do I know anybody that never ever had a site that did not require adaptive management, whether it was during construction because you hit a rock outcrop during grading that you didn't anticipate, or you hit groundwater before you expected, or whatever it is, right? So there's adaptive management during pretty much all phases of restoration. And then you go into this long-term management and monitoring period, which is the majority of the life of the mitigation site. But we need that period as well as adaptive management in there to ensure that the site is sustainable over the long term. Okay, so here's just an example of an overall monitoring program. And again, this links to those objectives, the performance standards, and the maintenance plan. So you have a list of qualitative tasks that go into the monitoring program. So these are, very basic, straightforward things like trash, debris, fencing. You want to get out there, see if your fencing's been destroyed, if there's been trespass, which we have a huge issue in a lot of urban areas, right? People want to cut paths and ride their bicycles through the beautiful open space, and that can destroy your mitigation site. Photo monitoring falls into this category at fixed locations. This is very valuable to regulators because we can't get to every site. Wetland hydrology observation, vegetation communities, etc. So it's qualitative. You're going out on a more regular interval, quarterly or biannually, and then maybe that curtails over as the site matures. But that way you can capture what's going on quickly and adapt the site as needed. And then there's these quantitative assessment performance standards and assessment tools, which I've already provided some examples here, but where you're assessing hydrology, vegetation, water quality, and then a functional and conditional assessment. So here's just a cool little photo monitoring grid here, and like I said, it is important. It's great to show your success in the future. It's nice for presentations in the future. And again, regulators cannot always get out to all the sites, so it's good to be able to show them sort of what's going on, and when you're out there, to be able to tag other things, invasive species, etc., and adapt. These qualitative monitoring memos, they're not required. I sometimes have required them when I was a regulator, and because it's regulators generally just get the annual report, right? The annual report is required, but you might not know what's gone on over the year prior. So these qualitative monitoring memos, they're very quick. It's just your photo sites and recommendations from the restoration ecologist of what needs to happen. This allows them to get their maintenance crews out there. It allows regulators to respond quickly to adaptive management requests. And it can be attached to that annual report to demonstrate that, you're working on the site. If things aren't going right, you're on it. Regulators care about that, right, for compliance. Okay, quantitative monitoring, we've talked about this, but this is that detailed data collection, typically that level 3 assessment tools. Let's see, some examples. No, I did not do that. Okay, so here's just one example from the Charleston district that I wanted to put out there from for their stream restoration monitoring requirements. They require very specific things for their stream restoration site. So pre-construction, they have water quality requirements, benthic macroinvertebrates requirements, and then post-construction requirements. So at least in that district, there's good guidance. You write your performance standards and your monitoring program to, at minimum, include these monitoring requirements, and you can go beyond that if necessary for the complexity of your site, but this is the minimum in that district. Okay, so quickly, adaptive management. Why do we do adaptive management? Right? We need to learn from our successes and failures, and this is really where I think that we are lacking in the regulatory field right now, because if something fails, we don't have a great database or a way to take that data and apply it and change our decisions in the future. And so it takes a long time for us to make better decisions. But adaptive management at the site-specific level helps you succeed, right? You are adapting at the time that when conditions change, maybe adapting in the future to climate change, adapting to things that might happen in the watershed, like a new development that's being constructed or whatever. I include this one example in here of a site when I was a regulator in LA district where I just went out, not really their adaptive management, it was my adaptive management. I went out and they hadn't removed all of those palm trees. There were like 15 palm trees in the channel. And this is not a beautiful stream restoration site. This was an old reclamation, rock reclamation area. And so it's steep in gradient, and it was more of a riffle pool complex and needed to be secured with these ungrouted engineered rock riffles. But I went out there during construction and like, why didn't you remove those palm trees? They're like, well, we didn't think you really meant that, but we did. And so they had to airlift those out because they completed the construction in advance. And it wasn't very expensive. I'm not that mean, but it did need to be done because these do spread. And if we let them kill them in place, they become a fire hazard in this area and neighbors complain. Right, so there's lots of reasons. So adaptive management occurs during construction, is this example. That was probably not a great example. And then how do you do adaptive management? You plan for it. You include contingencies in your financial assurances, and for long-term management in long-term management planning. You monitor on a regular basis, whether that's quarterly, biannually. You analyze those outcomes, and you adapt. You go out there. If it's something minor, you do it without needing to deal with your regulatory agencies. But if it's major, then you need to get your agencies involved right away and get out there and adapt. And then you incorporate results into your future actions. Don't keep submitting the same design, the same approach, and expecting a different outcome. Okay, so long-term management. In the mitigation rule, long-term management is broken into several different categories: site protection, sustainability, and again, we strive to have mitigation sites designed and located in the landscape where they could be self-sustainable. But management is almost always needed. There are very few examples that I can think of outside of a preservation of a very remote site surrounded by the natural, the forest, that doesn't need some level of management. Also in long-term management is adaptive management, again, to deal with those unforeseen deficiencies or climate change or whatever else that might happen after performance is met. And then long-term management, ensure the sustainability of the mitigation after performance. And so when does this happen? After performance is achieved. And then I just wanted to put in this, I think this is my last slide, long-term management and monitoring plans is one of the components that's required by the mitigation rule and the mitigation plan, but it's a separate document. Okay, so usually in the complete mitigation plan, you have a draft, you have a layout of what your what your long-term management plan will be, and then you revise that, you update it based on how your site has evolved in the 5 or 10-year monitoring period. And these in general are the elements that go into a long-term management plan. And you can see a lot of these tie back to the original design, background conditions, characterization of the site, etc., but also includes management strategies and tasks. Those are those performance standards and monitoring approaches and tools and adaptive management. And I'll just end with my zombie again, just to remind you that this is a monitoring program that never dies. It just all ties together, just keeps sort of going, and we continue to learn from that. And then I don't know if we're taking questions or not.
Excellent. Thank you so much, Michelle. That was really great. Given time, I'm going to move right over to Eric, but if you have questions for Michelle, type them in and we'll get them at the end. And that was a really great setup for the next 2 presentations, so we really appreciate it. Thank you. And Eric, I'm going to unmute you, and then I'm going to turn it over to you. There we are. Perfect. Thank you so much.
Can you hear me?
Yep, got you.
Great. And my screen is displayed?
Yes.
All right, super. Well, thanks everyone for spending some of your afternoon with me. I'm really excited to share with you a project that really we've just recently completed last calendar year to develop some new biological performance standards for stream mitigation here in Georgia. Well, the obligatory disclaimer, just in case some of my colleagues at headquarters hear me say something they think is crazy. So the outline of what I want to talk about is just to give you a little bit of context, the Georgia's mitigation experience, and also touch upon some of the evolution of mitigation guidance in Georgia as a lead-in to a discussion of these new biological performance standards that I was just referencing. So we've been at the stream mitigation game in Georgia for quite some time. Since the mid-90s, there's been almost 360 miles of stream mitigation in Georgia, and over 80% of that total has been approved and constructed since 2004. And we'll see the significance of that date in just a minute. Only a little over 100 miles, over 100 miles of stream mitigation has been approved since the 2008 mitigation rule that Michelle was just introducing. So, in Georgia, the first major federal mitigation banking guidance came out in 1995, and the Savannah District of the Army Corps of Engineers was right on the ball with its own local wetland banking guidelines that very same year. And there were a number of addendums and modifications to that guidance leading up to 2004. That was the date that I just referenced in the previous slide, where the Savannah District issued its mitigation crediting standard operating procedure. That is the method by which the Savannah District calculates the credits required for an authorized impact, as well as the credits capable of being generated at a mitigation site, particularly a mitigation bank. So again, in 2008, there in the bottom left of your screen, that was the date of the final mitigation rule. And 2018, just the middle of last year, the Savannah District began unveiling a comprehensive revision to its entire mitigation policies and program. I want to make a note here that the Savannah District mitigation guidelines included the use of biological indicators for stream mitigation projects as early as 2004, and specific biological success criteria have been included since 2009, and we'll talk about those in just a moment. So here's the mitigation crediting SOP from 2004, and again, approximately about 300 miles of stream mitigation in Georgia has been implemented under this crediting procedure. So what I really want to point out is that the lion's share of credits and these numbers here are used to tally up one box in each of these 5 categorical rows, if you will, are then multiplied by linear footage of the restoration project area to generate a credits per linear foot. And what I want to point out here is that the net benefit factor of this worksheet, which comprises the lion's share of the crediting, these are all action-based metrics rather than results-based metrics. And so you can see, moving from left to right, essentially what it comes down to is the more earth you move, the more credits you would get. And by the time the mitigation rule itself was published in 2008, the district was already realizing that maybe we need to revisit this. And in fact, they started revising it on a number of different occasions, and for various reasons weren't ever quite ready or able to push it over the finish line. But the ramifications of this action-based crediting was that some of our geographic service areas in Georgia now have a 25 to 30 year supply of stream mitigation credits available in them, based on historical records or future predictions of impacts in those watersheds. So I mentioned the stream biological performance standards that were in place since 2009. These were based on the state of Georgia ambient monitoring program and the multi-metric index that the state uses to assess condition classes for streams in Georgia pursuant to Section 305B of the Clean Water Act. So the biological performance standards in the mitigation guidelines for the district were based on a percent increase in that multi-metric index score at year 7, following construction of the project. And the amount of that increase was based on the condition of the stream pre-project or at baseline. So, for example, if the baseline condition of the stream was very poor or fair, by year 7, we wanted a 15% increase in the MBI score over the baseline score. And there were a number of problems with this, including the fact that in each of these condition classes, there's an unequal range of MBI scores, ranging from a very broad range in the fair category of 27 points, if you will, to a very narrow range in the good category of only 4 points. Furthermore, these targets were somewhat subjective and would sometimes lead to a situation where, in the very poor, and fair group, for example, 15% of 18, the range of the MBI score in the very poor class, was not equivalent really in any way to 15% of the fair range or 27 points. But the real icing on the cake is that this whole index, this multi-metric index, is primarily based on macroinvertebrate communities collected from much larger streams than we typically see mitigation projects undertaken on. So all of us, when we go out into the field, for the last decade or so, we feel like we can tell, or we hope we can see, that mitigation practices, mitigation projects have improved over time. Yet the biological recovery in these projects, available in the literature, is inconsistent at best. And so, kind of started asking ourselves, why is that? Is there truly no biological recovery at all? Is that recovery simply very slow and takes much longer than the standard required monitoring period associated with these projects? Or are we just not measuring the right thing? Maybe we haven't found the right indicator to give us some confidence looking forward that this site will in fact develop into the biological community that we hope it will. So I'm not a biologist, but looking around at some of these mitigation projects in the southeast, particularly in Georgia, where I've spent most of my time in the last 8 or 10 years or so, I started thinking that, well, gosh, if we could improve the site selection, get out of restoring a stream reach in the middle of a largely agricultural watershed with lots of denuded riparian zone and poor physical condition stream above our site. If we could improve site selection, we should be able to get greater amounts of organic matter input into our restored reach. And hopefully, if we site our mitigation project site in proximity to some intact donor tributaries where we'll get that organismal drift, we should see greater organism colonization in our restoration reach. And most of our restoration projects in Georgia are sort of to borrow a term from Roskin, the priority one kind of restoration, where you're basically excavating a whole new channel at a higher elevation on the landscape to replace a deeply entrenched and incised, perhaps old channelized stream on one side of the valley. And by doing so, we're reducing shear stress in that stream. We're reducing shear stress on the substrate and the channel banks because we're allowing high flows to access a floodplain more quickly, thereby reducing depth and hopefully velocity through that channel. And if we do that, we should be able to retain this organic matter and these organisms that our better site selection provides for us. So basically, by reducing shear stress and improving site selection, we should end up with more stable substrate and greater organic matter retention. And to me, my non-biologist self, I thought, well, that should lead to an increase in organisms that prefer stable substrate, like clingers, and increase organisms that feed on this coarse organic matter, like shredders. So let's talk about reference conditions for just a moment. Historically, our target, our reference has been the best of the best available on the landscape. And, I would like to propose that those are really idealized target conditions or aspirational conditions. And I recently found this article by McManamy and others that was just published a little over a year ago, and they refer to bearing streams that provide a point of reference, that bears witness to the desired endpoint rather than serving as the endpoint itself. And I thought that was interesting because that's sort of what we've done with our new biological performance standards, where we've generated performance curves instead of static criteria, and including along those curves a representative range of the entire stream condition continuum in our ecoregions here. So we needed lots of data to do this, right? So we got some help from our friends. The North Carolina State Ambient Monitoring Program is really, really robust. And because most of our stream mitigation in Georgia is on smaller perennial streams, I obtained from North Carolina a data set that they had graciously provided me that included data for almost 270 streams, all draining a watershed of 3 square miles or less. And I obtained these data from ecoregions common between North Carolina and Georgia. And we basically then used the bioclassification tiers that North Carolina establishes and allowed us to cluster sites within each of these ecoregions and then assign habits to each organism in the database, habits like clingers, burrowers, swimmers, etc., and also trophic habit or feeding guild like scrapers, shredders, collector-gatherers, etc. So then we were able to partition all of this into per ecoregion data sets and start some analysis. And these were the metrics that we began with. Again, my non-biologist self, I went into this thinking that, or hoping that clingers and shredders would prove illustrative just based on deduction of what the objectives of stream mitigation typically was in Georgia. And the first thing we did was look at any correlation or any relationship between our target metrics and watershed size, and there was none. Again, we're looking at only very small streams, less than 3 square miles. And then we just simply did box plots per condition class, like E for excellent. We lumped the middle 3 tiers, good, fair, and fair, into a single group, and then left poor off by itself. I should first say that because the state of North Carolina does not use strict abundances of organisms in its data, that is, they basically use rare, common, or abundant instead of percentage of single organisms per taxa in their multi-metric index. We used all of our metrics, or all of our analysis was based on the proportion of taxa richness per each of these metrics that we're analyzing. So for example, on the left here, this is a proportion of mayfly, stonefly, and caddisfly taxa richness. And on the bottom right, that is a proportion of scraper taxa richness. And so generally, you have a discriminatory metric on the upper left and a non-discriminatory metric on the bottom right. We did this with species level data and ultimately did it again with genus level data. And we ended up with these 4 selected metrics. Proportion mayflies, stoneflies, caddisflies, proportion clingers, proportion shredders, and proportion burrowers. So at this point, I was really excited that proportion clingers and proportion shredders showed up to be suggesting some trends in these North Carolina data, because those were exactly the things that I was hoping or had deduced just simply based on the logic of a non-biologist. So we sought correlations among these 4 metrics and to test for redundancy primarily. And basically, no 2 of our metrics had a correlation higher than the threshold used by EPA's National Rivers and Streams Assessment. So we retained all 4 of them. We also reviewed correlations between all of the metrics and the physiochemical water quality parameters, in-stream habitat, and watershed land use documented by the biologists in North Carolina. We had to standardize these metrics because we wanted to combine them into a single index, but the proportion within each of our 4 variables varied. For example, here, there was almost a 23% range in our EPT richness metrics, and less than a 14% range in our shredder richness metrics. I'm showing you only the Piedmont physiographic region here. The disparity in these percentile ranges was even greater in the Blue Ridge ecoregion. So we standardized our data using the percent of standard method across the full range of sites from poor to excellent in each ecoregion, so that these 4 metrics could be uniformly compared and aggregated. So then, despite that we used the whole range of data for standardization, to develop the mitigation performance curves themselves, we used only the values within that middle tier of condition, that good, fair to fair bioclassification group. Well, why did we do that? Well, we did that because we made the decision that we're not going to grant biological condition credit to a stream mitigation project that is still in the poor condition class at the end of its monitoring period. Essentially, there has been no biological improvement. So we elected not to include the poor group in the compilation of our curves. We also excluded the excellent sites from the performance curves only to avoid depressing the index values and the potential mitigation credit generation to something less than what we believe is more likely to represent post-mitigation biological stream conditions in the good, fair group. So then we just simply took the percentiles of each metric's standardized value and built linear regression performance curves from each one. We've built spreadsheet templates to automate the standardization of practitioners' data and the calculation of these index values represented on this slide. And so not only are these performance standards, but we're actually utilizing these to grant mitigation credit. So it's really incumbent on practitioners to select sites wisely, to pay really close attention to their sites and adaptively manage them as necessary, as Michelle was advocating in the first presentation, because the difference in their index score at the end of their monitoring period relative to baseline or pre-project conditions drive the biological credit to be granted to their mitigation projects. So all of this has been done on borrowed data, if you will, data borrowed from North Carolina. In conclusion, I do want to introduce the fact that we are actually, as we speak, collecting biological community data from 90 small streams in the Georgia coastal plain. We're collecting this data ourselves, and from that data, we will run or undertake the same type of analysis that we used, as I've just described, trying to, again, identify those metrics that we believe will best represent biological improvement in streams, as opposed to using surrogates like physical stream habitat, which is good, but it doesn't necessarily equate to true biological community improvement, the so-called field of dreams proxy. That's all I have. So I'd be happy to take questions at either now or after Phil's presentation.
Excellent. Thank you so much, Eric. That was really great. A really good description of the project. If anyone has questions, please go ahead and type them in. We may move on to Phil, but we'll try to get to them at the end. I just have a question, Eric, about how implementation is going and if you're getting feedback from providers on this effort.
We have in Georgia an association comprised of mitigation practitioners, mitigation bank sponsors, NGOs, and attorneys that work with those groups. And we consulted regularly throughout the development of this with the technical committee of that association. So it wasn't a surprise to anyone, I should say. They were right there with us. Whether they fully love it or fully hate it, I can't say.
Right.
But it's been going. Rollout was fine. It's so new, however, that we have not actually utilized it yet in the field.
Sure. Okay. Great. Thanks. I'm going to switch over to Phil now. Thank you again, Eric. That was a really excellent presentation. And Phil, I think you're muted on your end, so when you're ready. There we go.
Okay.
Thanks again, Eric.
All right. Are you seeing my, oh boy, I got echo. Rebecca, I'm getting some echo.
Oh, you are? Okay. You sound good on my end. Make sure that your computer, are you on your phone or the computer? The computer.
I'm on the computer.
Yeah.
So I'm just. Can you hear me?
Yeah.
No.
Oh. can hear you.
Yeah, I'm just having there's just a ton of echo when I'm talking.
Oh no.
It wasn't happening earlier, so I'm not sure. Audio. I'm not exactly sure what to do about it.
Maybe, yeah.
If you hear me okay, I'll just continue and try not to listen too much to the echo.
Okay. Yeah, we can hear you okay, and hope maybe if you turn down your volume on your computer, that might help.
Okay.
And I'll let you know if we can't hear you, but so far so good.
Okay. Can you hear me all right?
Yes. We can hear you when you do that, yeah.
Okay.
But right now we're seeing your screensaver and not your slides.
All right. So let me just apologize for that. Where is the video? View. Well, we had this all straightened out earlier. And now I'm trying to go screen. No. That's not it. Still not getting it, are you?
Well, I see your PowerPoint now.
Yeah, but you're not getting the, boy, which slide do you?
And if you go to your monitors and switch monitors.
Yeah, I'm trying, but I don't see.
I mean, on your PowerPoint, that's how Michelle fixed it.
Okay.
Oh, it was on that front screen there. Okay, there we go.
I'm not sure. That's not how we switched it before, so that's why I'm confused.
Well, maybe if you go to your slideshow now, we might be good to go.
Okay. No, it's still showing up on my other screen. Where's this change screen settings? Because we did this the other day and it worked fine, and now I just don't see it. It usually gave.
Yeah.
Okay.
Click on the Go Meeting thing that I did. So that little blue round dealio that you have on the right there. You see the little blue icon over to the right, or down on the bottom of your screen where it shows the Go To Meeting blue flower.
Okay. I don't.
See on the bottom of your screen, do you have the little Go To Meeting? There you go. Click on that. And then I can't see yours, but if you had, that's what I had been able to switch screen from, not from PowerPoint, but from that.
Yeah. Audience view. I think this is where we did it last time, but now I'm not. Shoot. I can't believe this is, we.
Well, maybe we should just go through like this because we can see your slides on this.
Yeah, well, actually, I have a way of, all right, I can go through, if you can see the slides, I'll just go through like this. I really apologize. I'm not sure why.
If you want to turn down your computer microphone again, I guess others are getting the echo as well. So once you get started, yeah, great, thank you.
Can you still hear me?
Yes.
Okay. All right. My apologies for the audio tech, the issues with the screen. We had gone through this so we wouldn't have this problem, but now I'm not sure what's going on. So I'm going to shift gears a little bit, and I'm going to talk about monitoring fish response to habitat restoration and mitigation in the Pacific Northwest, and monitoring at different scales. We've talked a lot of the stuff you've seen is on kind of a project scale or reach scale. I'm going to talk about watershed and regional scales and some of the successes and challenges we've had. Okay, now that's not working. Okay, so I'm going to give you a little background on restoration in the West Coast and the Pacific Northwest, talk about some of the major scales and some lessons we've learned, the strengths and weaknesses, and kind of some recommendations for monitoring. Just to give you some background, we're in really restoration and mitigation in the Pacific Northwest and also on the West Coast. Has really been a growth industry. There's probably about 500 million a year spent on restoration of rivers and streams. Most of that is being driven by Endangered Species Act listings. Most watersheds have anywhere from 1 to 4 or 5 species of salmon, trout, or other fish listed as threatened and endangered. And most of the money being spent is on restoration of salmon streams to try and recover salmon. So pretty massive efforts underway and a variety of large state and federal programs to do restoration. And it includes the things that you're covering with mitigation, the same kind of practices. Very small fraction of the monitoring is being spent, or of the money is being spent on monitoring. I think the estimates are on the order of maybe 7% or so is spent on monitoring and evaluation. And the different tiers that Michelle talked about earlier. I mean, a lot of the stuff we talk about is the different types of monitoring. I'm really going to focus on kind of that tier 3, which we would often call effectiveness and validation monitoring. And so we've put some guidance together on how to do the monitoring and evaluation of restoration projects. And from what we've seen, whether the programs are successful at evaluating the success of these restoration and mitigation efforts often depends on whether they followed these different steps in the monitoring program. I'm not going to go through all of these, but I'm going to touch on a couple of these steps because I think they'll set the stage for talking about what we've learned from monitoring and evaluation at the different scales. And so one of the challenges we're faced with often is people are asking, well, what's the questions we're going to ask? What's the questions for your monitoring program? This should really drive the whole thing. And what we've largely, it comes down, I mean, there's lots of different questions you could ask, but really there's 3 major questions that we've been asking about these different salmon habitat restoration projects. It's 1, what is the effect of a particular project on habitat and fish abundance? It's really the individual project. This is kind of the oldest form of monitoring and valuation. I mean, I think the earliest studies on fish response to restoration in North America go back to the 1930s, and they were at an individual project level. But we've got these different restoration programs, and I'll talk about some of the large ones, and they really are more interested in how effective are different categories of techniques. So the other question that's often occurring at a reach scale is, well, not what's the effect of this one project, but what's the effect of projects like this on habitat and fish abundance? So what's the effect of re-meandering channels, or what's the effect of riparian planting projects? How effective are those projects? And then, since most of these efforts are really to try and recover whole watersheds or salmon or trout populations, the questions have been more focusing now on, well, what's the watershed scale response? How are the watershed conditions and habitat changing, and how are the fish populations, not in the given reach, but at the whole population level, responding? So those questions are really occurring at this reach, watershed, and regional restoration program scale. And there's really, these aren't laboratory studies, so the kind of monitoring designs that you can use, there's just a handful that really can be applied to these things. There's these before and after study designs, which you can see is the first one there on the list. And the major challenge with just a simple before-after design is if you don't see you don't know if that's due to your restoration or that's just a trend in time. So, that's why the before-after control impact or the BACI design was implemented, where you're monitoring both the treatment and control, and you can apply that at multiple sites so that you have a multiple BACI, and that's how that's being rolled up to try and do it at a regional scale. But in a lot of cases, both the before, after, and the BACI designs require a lot of pre-project monitoring. So the other approach that's been taken, where we have a lot of projects that have been implemented, is an extensive post-treatment design, sometimes called a control impact design, where we're monitoring paired treatments and controls. And the objective there is really, you're just monitoring these post-treatment and just comparing. You're not trying to find out about individual of project effectiveness, but just as a group, how, are we seeing, on average, are there more the conditions and the fish numbers higher in the treatments than the controls? And so it really gives you the average response. So when you match those up to the different scales we're looking at, you can look at the kind of study designs that or monitoring designs one can use. The project, the reach level, you can use a before, after, a BACI design, the watershed or the basin scale. And I should say the reach scale on most of this monitoring is occurring anywhere on, a few hundred meters to up to a couple kilometers would be the reach scale. A watershed or basin scale is going to be across anywhere from basins that are 20 square kilometers to 20,000 square kilometers, but these can be pretty big basins. And then the regional is just across a whole state or region. But these are the different designs that are typically applied and can work on those kind of scenarios. So what I'd like to do is go through an example or one or two case studies for each one of these. I'm just going to touch briefly on the reach scale one, because that's the most tractable. The one that has been the most challenging is this watershed or regional scale. So this slide here is, I could use some examples from the Pacific Northwest, but I use this example, which is from a study from Hunt in the early 70s, because it was one of the best designed examples, where they had lots of pre-project monitoring, lots of post-project monitoring of fish response to restoration, stream restoration at a reach scale, and they monitored 3 controls. And it's just a good example, and it's what people have done historically. And as long as you're able to collect the data consistently over time, and keep these funded, it's really, there hasn't been too many issues with implementing this kind of design, at least relative to some of the watershed and regional projects. So I want to shift to moving and talking about a watershed scale. And this is, this is again occurring in anywhere from 50 to maybe a few thousands or thousands of square kilometers, pretty basins that can be quite sizable. And there was some early studies done on this that were very successful, and it's been implemented in the last 10 or 20 years. There's like 18 of these going on across the Pacific Northwest and West Coast. Not all of them are on this map that you'll see here, but there's a few more in California and in British Columbia. And it was really a popular approach that's been implemented. And a lot of that popularity had to do with, there was a study done on a couple Oregon coastal streams, and these watersheds were on the order of 100 or 200 square kilometers, paired watersheds. They restored a large part of the watershed and saw a fairly massive increase in the number of juvenile fish. These are juvenile coho salmon smolts, which are just the migrants when they go to sea. So this was a very well-designed, intensively monitored, what we call an intensively monitored watershed study that was very successful. I've been involved in a couple others of these that have not been as successful, and this is an example of some data from one for coho salmon and steelhead trout numbers on some watersheds that flow into the Strait of Juan de Fuca, which is just extreme northwest Washington, and just across from Canada. These three small watersheds we've been monitoring. You can see a couple big differences here. The restoration took several years to complete. And actually, there's another wave of it that's occurring right now. And there really is no discernible change in fish numbers, and there was no discernible change in fish habitat either. This was this is a pretty long-term and expensive effort, and not a lot to show for it. And that is pretty consistent with most of these intensively monitored watersheds. Most have not been successful. There's a couple really highly successful ones. But most of the challenges have not so much been on design, but because it's really on the implementation. It's trying to control the timing of the restoration, as you see on that previous example, that it'd be ideal if all the restoration occurred in 1 year, but typically when you're working across a watershed, it may take several years to get the restoration or the mitigation completed. There's issues with the field protocols and consistency through time. And the bigger the watershed, the more individuals involved in monitoring and the more coordination is needed. And that runs into issues with the timing of the monitoring, the management of the data. A lot of these projects have not had the data analyzed annually, and they've gotten several years into it before they realized there was some problems with the protocols and the data collection. And that's run into some issues with the funding, because the funders are getting a little tired of things drifting off track. So it really appears that this watershed scale monitoring, which really is the ideal thing you would think, is really only tractable on smaller watersheds that have a pretty simple ownership. A lot of state and federal land that you can control things on. So the other scale I wanted to talk about is and Rebecca, how am I doing time-wise?
I think you're doing okay. You have about 10 more minutes.
Okay. So at the region or program scale, and I want to go through two large restoration programs or examples from each of these two. One is the Columbia Basin Fish and Wildlife Program. It's the Bonneville Power Administration's Columbia Basin Fish and Wildlife Program. It's a mitigation for the Columbia River hydropower system. BPA, the Bonneville Power Administration, spends about $180 million a year on mitigation for fish and wildlife habitat, and there has been thousands of projects implemented across the basin over the last 2 or 3 decades. The other program is the Pacific Coastal Salmon Recovery Fund. It's a federally funded effort that the federal government gives money to the states to do salmon habitat restoration. And it's ranged from 30 to 100 million a year across the states. And I think the state of Washington alone has spent $1 billion on salmon habitat restoration in the last 15, 20 years. So these are pretty big programs, both of which designed programmatic monitoring and evaluation programs to try and understand the effectiveness of their actions. So the first one I'm going to talk about is the State of Washington Salmon Recovery Funding Board program, and they used they developed a program back in 2004 to start evaluating these projects, and they categorized them into different action types, restoration types, fish passage, riparian planning, in-stream structures, livestock exclusion, etc. Then they sampled 10 to 20 of each type, a subset, a random sample. I'm just going to show you an example from some of their in-stream projects where they monitored 23 projects. We were contracted to evaluate the program and to complete the monitoring in the last year of monitoring. But their program had been going for quite a while, and 1 year pre-project data, several years of post-project data. They had their protocols were some basic. We have pretty good stream. The streams are pretty clear here, so you can actually do snorkel surveys to count fish in almost all the streams. The habitat surveys were modified EPA EMAP protocols, which are great for what EPA was using them for, but not necessarily measuring the right things that would respond to restoration projects. And then there was an effort to switch to a different habitat monitoring program, the Columbia Habitat Monitoring Program, in 2012, and that program would take about to monitor 500 meters of stream takes a crew about 2 or 3 days to map the whole thing. Unfortunately, those two programs are not compatible, which led to some data issues. And then we tried a variety of analyses on this. Really, the results of this one were pretty underwhelming in that none of the metrics really showed a response to restoration, except for large wood placement. But the main treatment occurring was placement of large wood. So that isn't really that's not really a response. That's something that if it didn't happen, it would be shocking. And then some of the metrics like vertical pool profile area or mean residual profile depth, those are things that came out of the EMAP program, which aren't actual direct measurements of pool area or residual depth, which are two factors known to be strongly correlated with salmon and trout response. So there was a number of, this is pretty underwhelming results, but the end of it was that we're not sure that's not really that the restoration wasn't good, it's that there was a bunch of issues with the implementation of the monitoring. Now for the BPA Columbia Fish and Wildlife Program for in-stream projects, they took a different tack, which was to use an extensive post-treatment design, partly because they had more than 200 projects, wood placement projects implemented across the basin over the last 15 years. And this was simply looking at paired treatments and controls at 30 sites. The y-axis is the mean fish or habitat response, and the x-axis is just the different species of fish. And you can see in most cases, we saw significant increases in juvenile steelhead, juvenile Chinook salmon, juvenile coho salmon, juvenile cutthroat trout. They're about 2 to 3 times more of the fish in the restored reaches than the control reaches, the unrestored reaches. And that's pretty typical what we've seen in coastal areas with other species for wood placement projects. So what we've seen from the these different regional programs is there's been a lot of challenges. There's some big successes, but there's been a lot of challenges, and these challenges have some to do with staying on track on the goals and questions, the site selection, using appropriate protocols, appropriate data collection, being able to time the restoration appropriately, and data management and other issues. And just to kind of, I think I'm probably getting short on time here, so I'm going to speed this up a little bit. But when it comes to site selection, we've seen a lot of cases that there was sort of poor selection of treatments and controls. There were cases where there probably wasn't a control that was suitable, and they included it in the monitoring program anyways, but that makes it hard to detect a response. The protocols that were selected, some cases, if they were specifically designed for that type of restoration activity, they seem to work pretty well, but the attempts to use some off-the-shelf protocols haven't worked too well, and in some cases we went really with some very started monitoring dozens of projects with a protocol that hadn't been tested. So you really got to do some pilots first. There's been a number of data collection issues that have come up through time, and most of these emphasize the need to ensure people are well trained and kind of limit the number of people involved. I talked about the timing of restoration. The data management, particularly for these large intensely monitored watershed and regional programs that generate lots and lots of data. We've seen a number of data management issues, and just it emphasized the importance of a publicly accessible database. And the reporting side of things, I think we've seen that the best reports have been those that really stick to a traditional scientific report. I think these large programs. There's a tendency to include lots of graphics and lots of interesting tangential studies, and not answer some of the main questions. And also the lack of periodic reporting has been a challenge on some of these big programs, and it kind of emphasizes the need for periodic scientific review, independent scientific review. So there's been just a summary on this. We can monitor fish and habitat response at a number of scales, and we've had success at doing that. There's been some big successes, but there's been a number of failures of the monitoring, and a lot of that, some of it's technical, but really a lot of it's challenges with implementation. And when you scale up to do things at a region or a watershed, it just emphasizes the importance of staying on target and coordination and following the key steps in the monitoring program. So that's kind of a quick tour through some of the lessons we've learned and the challenges we've seen with monitoring at different scales in the Pacific Northwest. And with that, I can take any questions, so I'm not sure we have any time.
Thank you so much. Can you hear me okay, Phil?
Yeah.
Okay. Well, thank you so much for that. That was an excellent presentation. We are at the end of our scheduled time, but I do want to give folks who want to stay on the line a chance to ask a few questions. And I do have one for you, Phil, if you're all willing to stay on for a few minutes.
Yeah.
So the question is, Phil is touching on the difficulties of monitoring and data collection protocols, essentially when a large number of people get involved. Can you speak to the efforts to standardize these protocols in such a way that monitoring is as accurate as possible with as little subjectivity as possible, especially considering third-party monitoring for mitigation credits is not often used? So if you want to touch on that, or if anyone else on the line wants to.
So I'm sorry. So third-party monitoring and evaluation is not often used, meaning the ones who do the restoration or the mitigation also do the monitoring. Is that correct?
Right.
Yeah, I mean, I think the part of the challenge with these monitoring programs, and there were standardized protocols that were used, but there were two challenges. One is that the protocols were changed through time, and some of the data collection issues just had to do with timing and not collecting them at a consistent time of year. So going back to one site, the same site, instead of going every summer in August, sometimes they went in August and sometimes they went in November. There's kind of surprising things that happen, but I think that I think you just have to make sure that the protocols have been piloted and tested first. And once you know they work, it's easy enough to outline specifically when they need to be done, and specifically what needs to be collected and how it's done. It seems that some of this has been just not piloting the methods and adequately, and then doing adequate training of the field crews, which can be, I think, can be overcome. And we've had some successes with it, but there's some big programs that have kind of stumbled.
Great, thanks. Eric, I have a question for you, and I unmuted you. One of the graphs in the beginning of your presentation showed a big drop-off in credits generated in recent years. And the question is, will the banks generating legacy credits adopt the new standards, or is it only for banks or compensatory mitigation projects that are new or that are initiated after the credits, new protocol was in place?
That's a great question, Rebecca. The banks with existing credits will basically have a correction factor, for lack of a better word, applied to their credits, so that a bank selling so-called old credits and a bank selling so-called new credits are on the same playing field.
Okay, great, thanks. If anyone else has any questions, I don't see any coming in. And I know we're at the end of our time, so I do want to let our speakers go if we don't have any additional questions. Apologies to everyone for some of our technical issues today. I know many of you asked about the presentations, and we're working really hard to get those uploaded to the website. We did have some technical issues with that as well. But I hope that the amazing presentations made up for our audio difficulties today. So again, thank you all for joining us. We really appreciate it. Thank you so much to our presenters. They were 3 excellent presentations with a lot of great information. We will be sending out invites for the next webinars very shortly. We have one coming up next month, and then as we move along through the spring. So again, appreciate all of you attending and hope to see you soon on a webinar soon. Thanks so much.